welcome back to my channel. This is Ananta with you. Hope all you are fine. Today's topic is heat treatments, the different types of heat treatments and their requirement. You can get it from this video. And this is very important video and this is very helpful for those who want to attend the CSWIP examinations. So let's start. First, you have to know the heat treatment of steels. We have different elements. All heat treatment are basically cycles of three elements. We should know first things in heat treatment. There are three things are there element. One is heating. We have to do first heating. Then you have to do holding in that temperature and the time that mentioned, that is called the soaking time. And then you have to do cooling. So this is the three process we have to do: heating, first heating, then holding, then cooling. Then you finish the heat treatment. So these three elements you should know. Post-oil heat treatment are used to change the properties of oiled metal. That is the controlling the formation of structure. So what means by properties? Properties means you can say the tensile strength, yield strength, ductility. So these things will be improved after the post-oil heat treatment. And the controlling of formation of structure. So there is the formation of structure, it should be controlled by the post-oil heat treatment. This heat treatment what actually, this is a method for, you can say, the reducing the residual stress and redistribute the residual stress in the material. That is introduced by when you are doing the welding. So this is actually reduce the residual stress and redistribute the residual stress. Now the heat input, sorry, the preheat treatment are usually basically to increase the weldability. Preheat treatment, the post-weld heat treatment is different. The preheat is the before the welding, you can say. The preheat treatment are used basically to increase the weldability, control expansion and contraction forces during welding. You have to know very well the control of expansion and contraction, when it will happen. If preheat will not apply, then the flow down of cooling rate will be very high. Then the control of expansion and contraction forces will be there and that area will be definitely cracked. That's why the preheat is always mandatory requirement. If you use any low hydrogen electrode in a material, in a particular high thickness material, you have to use the preheat because of the slow down the cooling rate and it impacted. If it is not preheat done, then it can be contraction of and expansion of that area. It can be cause cracking. So you understand the PWHT what is this and preheat treatment what is this. Now the heat treatment, why it's required? The heat treatment, why it is required? Because the heat treatment develop the hardness, material softness, and improve the mechanical properties such a way like tensile strength, yield strength, ductility, etc. So first so things is that heat treatment when we need because of hardness, improve the softness, improve the mechanical property such as tensile strength, yield strength and ductility. So the questions is coming, what type of heat treatment is need for the material? So depends upon the industry and the client requirement and depends on the specification. So what you need in that basis you have to know. So let's start the process now. So you see the process here. The relevant variables for heat treatment process which must be carefully controlled are as follows. So the relevant, which type of variable is required for heat treatment process, it should be carefully, you should know. It should be controlled carefully. First thing is heating rate. It should be as per the approved procedure. Temperature attained, which temperature you need to attain for this particular post oil heat treatment, so it should be also as per the specification. Without specification you cannot do anything. And the time at the attained temperature, so which time, soak time, it is actually soaking time, how much soaking time is required. So these things you have to know, and this should be always controlled when you are doing the heat treatment. So you see that also the cooling rate, these four things are very important when you are doing the PWST. First thing is heating rate, second is temperature attained, how much temperature is attained in that particular material, how much temperature, how much time is required for the soaking time, and the cooling rate. Cooling rate, the heating rate is there and the cooling rate. So these four things is very important for control the heat treatment process. Now the basic heat treatments are, will be explained one by one. First one is annealing. Annealing is one of the heat treatment. Another is hardening, one of the heat treatment. Another is stress relieving. We'll go one by one with explanation. What is the basic requirement? Fourth is normalizing. Fifth is tempering, and the last one is the preheating. So this six procedure, the heat treatment, the procedure of heat treatment is mentioned here. This is different type of requirement as per the client asking you that this requirement you need for the particular this steel, so you have to do that way only. Now the method of applying the heat to the material may vary from procedure to procedure. So I just explained to you the method of applying. You are applying any methods of the above, like annealing you are mentioning, you are doing the annealing for the particular steel, so it depends on the procedure. If procedure mentioned that you have to do annealing, you have to do annealing. So that is flame, electrical resistance, and the furnaces. So that procedure, it may be flame, it may be electrical resistance, you can do the heat treatment, also the furnaces you can do the heat treatment. So the sixth heat treatment procedure is there. Now we'll go one by one the annealing. What is annealing and why? What is the requirement of annealing? Temperature, it is required the 920 degree centigrade hold for a sufficient time. So 920 degree centigrade it should reach there. First temperature should reach 920 degree centigrade and it should be hold for sufficient time. That is called the soaking time. And cooling is furnace cool to 650 degree centigrade, then cool down the air. So annealing, the cooling procedure is, first you have to do cool by furnace up to 650 degree centigrade, then you have to cool down the air. The result, what will be the result in annealing? The produces a very soft, low hardness material suitable for cold working or machining operation, decreases toughness and lower yield stress. So I already told you this is the requirement as per the industry. If industry told that, or specification told, or the client requirement told that you need the low hardness material or very soft, so we have to do the process, we have to choose the annealing. Now the normalizing. Normalizing, same things, the temperature it will reach to 920 degrees centigrade and you have to hold for sufficient time, that is called the soaking time. Now cooling. Cooling, there is a difference with annealing. The annealing cooling is furnace will be first 650 degrees centigrade, then cool down the air. But normalizing, the cooling is slow cool in air. It should be only cooling in air, not in the furnaces. So you understand the temperature and the cooling. Now the result will there, the relief in the internal stresses, improve mechanical properties and increases toughness, grain refinement. So normalizing, why we do? Because of internal stress, if it is there, then it will be relieved and improve the mechanical properties like increases toughness, grain refinement. So this is normalizing. Now we'll go the quench harden. The quench harden, the temperature, it also the 920 degree centigrade hold for sufficient time. You have to do the same things. 90 to 920 degree centigrade, you have to reach there first, then you have to hold for sufficient time. Then cooling is first cool, quench in water or oil. So this cooling is different than handling and normalizing. This cooling is first cooling. It should be cooling by very fast. By putting the water in that steel or oil in the steel, then it will be cooling very fast. So cooling is very fast, that is called quench harden. The result is hardened carbon steel. After this treatment, the material is very hard and highly stressed. So this material will be very hard and highly stressed. The material is brittle anytime but with a high tensile strength. So the material will be brittle, but this tensile strength will be very high. So it's as per the requirement. Again, I said to you. So this is the requirement of the quench harden. Now the tempering. Temperature. The tempering is the temperature should be 250 to 680 degrees centigrade hold for sufficient time. So you have to reach in between 250 to 680 degrees centigrade and you have to hold for sufficient time, that is called soaking time. And cooling, it should be also slow cool in air, that is air cooling only, and the result will be the relief residual stress, improve mechanical properties and increase toughness, may also be used in reduce hydrogen level. So the same thing is normalizing and tempering, only the temperature is different. Only the temperature is different in normalizing and tempering, otherwise cooling in slow cool in air. And result also same, only it is in tempering, it will be used to reduce the hydrogen level. So if it is hydrogen level is more or is there in that steel, definitely it will be controlled there in tempering. Now stress relief. Stress relief is temperature will be 550 to 680 degrees centigrade hold for sufficient time. You have to hold that temperature 550 to 680 degrees centigrade in between. Cooling, it also cooling slow cool in air, cooling only in air, and result is relieve residual stresses, improve mechanical properties, same things as normalizing, tempering and stress relief. Only also the tempering and stress relief is same almost, but temperature is, that is the different between the different maintain the temperature. It was the tempering is 250 to 680. Now here is 550 to 680. So different types of temperature. Post hydrogen release, this is very important. One, we have do the heat treatment in industry, the post hydrogen release. How you do? Temperature, it should be approximately 250 degrees centigrade hold up to 10 hours. So you have to hold this 250 degrees centigrade, that material, up to reach their first 250 degrees centigrade, then you have to hold for 10 hours. Yeah, then after 10 hours if finish, then you have to cool that material in air, slow cool, and result is relieves residual hydrogen. Wherever in hydrogen is there, residual hydrogen, it will be relieved from this post hydrogen release treatment. Now is preheat. Why we use the preheat? We can preheat metal and alloys when welding for a number of reasons. In number of reasons, we are using the preheat metal and alloys. Primarily, we use most preheat to achieve one or more following. So, primarily we can say the preheat why you are using, you can say that to control the structure of weld metal and hedge on cooling. So, in preheat, why we need the weld metal, the structure of the weld metal, you can see the formation of structure and the hedge on cooling. So, in the cooling, the control, we can control the structure and the weld metal and the hedge. Second is to improve the diffusion of gas molecules through an atomic structure. You see, if there is a gas molecule inside this parent metal, Definitely in preheat, it will be diffused, means it will be improved. There should not be any gas molecules at there when you are doing the welding. 3 is to control the effects of expansion and contraction. Again, I said to you earlierly, expansion and contraction is the main factor to slow down the cooling rate. If it is cooling rate is very high, then definitely it will be problem the expansion of contraction, and it can cause a crack. So preheat control the formation and undesirable microstructure that are produced from rapid cooling. If you were preheat not you have not done the preheat but it is required, what will happen? In that case, rapid cooling will be there. In rapid cooling, what will happen in steel? The martensite will be generated. So martensite is in form of the carbon equivalent CE diagram. So in C diagram, you can say the martensite is a harder material and it will be brittle anytime. So the material will be in problem when you are in static load. Any type of load is there, then definitely it will be brittle. So that's why we need the slow down the cooling rate. That's we need the preheat. Preheat temperature are arrived by taking into consideration three following. So consideration the following arrived. First is the heat input is important. Second is the carbon equivalent. Third is the combined material thickness. And fourth is the hydrogen scale required. So these four things is important, depends on the preheat temperature. Advantages of preheat. What is the advantages of preheat? Why we do preheat? What is the advantages? First is the slow down the cooling rate, which reduces the risk of hardening. So if slow down the cooling rate, then there is not chance any form of hardening. So hardening will not be there. Allows allow absorb hydrogen a better opportunity of diffusing out, thereby reducing the risk of cracking. So hydrogen absorb the diffusible, it will remove by the applying of preheat. So there will be reducing the risk of cracking. Third is remove moisture from the material being welded. So which material will be welded? That material, if it is do the preheat, definitely it remove the moisture. Fourth is improves overall fusion characteristics. If preheat is there, definitely the material is hot, and again you are doing when you are doing the arc generating in that particular joint, though so already that joint is already in heated, so it will be good fusion characteristics. Lower stresses between the weld metal and parent material by ensuring a more uniform expansion and contraction. So the preheat will be happen, lower stresses will be generated. So all stresses will be removed by applying of the preheat. So you understand the advantages of preheat, and also you understand all the requirement of the heat treatment. So methods, how you measuring the preheat? By temperature indicating grinds, you know the temple stick. Now it is used the infrared thermometer. So these things you can use to measure the preheat. Thermocouples of touch pyrometers. We can use this thermocouple of touch pyrometers to use to check the preheat temperature, how much at interval along around the joint to be welded. The number of measurement taken must allow to the inspect must allow the inspector to be confident that the required temperature has been reached. So number of measurement we have to take a must and allow the inspector that required temperature has been reached properly. In certain cases, the preheat must be maintained a certain distance back from the joint faces. So in certain cases we have to do the preheat must be maintained from a certain distance. If a gas flame is being used for preheat application, the temperature should be taken from the opposite side of the heat source. So if you are using any gas flame for a particular joint, So you have to use the temperature gun by opposite of the heat source. We have to use for temperature gun to measure the preheat. If this is not possible, time must be allowed before taking the preheat temperature. That is example, you can say 2 minutes for 25 mm thickness. You can use. So this is for method of measuring preheat. I think hope you understand the basic concept of preheat and the post-heat treatment and what are the used for annealing, normalizing, tempering, hardening, all these things you can get the details here. So thank you very much. Any questions you have? How? So questions I am giving to you. If you have any if you have any answer for the particular questions, definitely there is answer. If you if you have any query for particular questions, so you can give me message to my inbox. I will explain to you. So there is 5 question is there. How can the level of hardness to be controlled in the hedge? I already explained there. What is the maximum recommended heat treatment temperature for steel weldment? Also, I explain in the particular process we already mentioned. What are the 4 main considerations for determining preheat temperature? So definitely, I already that is one is the carbon equivalent. Like this way, there is 4 things are there. Question number 4: what factor need to be checked controlling during a heat treatment process? Also, it's mentioned in this video. And the question number 5, which heat treatment process is required when maximum ductility is required? For example, for extensive cold working operation. So this 5 question is there. I think you have all answered for these questions. If you have any query, just send a message to me. Thanks for watching the video. Please like, share and subscribe my channel to get the regular video. Thanks a lot.